Good morning, students. In previous class we have learned oxidation state or oxidation number and redox reactions in terms of oxidation state. Now we will discuss about types of redox reactions. Here there are four types of redox reactions which are combination reactions, decomposition reactions, displacement redox reactions. In this further again classified into two types, that is metal displacement redox reactions and non-metal displacement redox reactions. And the fourth one is disproportionation reactions. So these are all first of all redox reactions and further again classified into four types. So first we will see the combination redox reactions. So generally the definition, first we will see the definition. A redox reactions in which compounds are formed by the combining of components is called combination redox reactions. In these reactions, components are converted into compounds. We will see the examples. All combustion reactions are example for the combination reactions. For example, here we will see sulfur is reacted with oxygen to form sulfur dioxide. You will see here sulfur oxidation state is 0. Oxygen oxidation state is also 0. But after the compound formation, the sulfur is converted into +4 oxidation state, 0 to +4 oxidation state, and the oxygen converted into 0 to here -2 oxidation state. That means sulfur oxidation state increases, that's why sulfur is oxidized, and oxidation state will be reduced, that's why oxygen undergo reduction. Next, so here two different components are combined to form a compound, that's why this reaction is called combination redox reaction. It means just elements are combined to form a compounds. Next, another example here, carbon is also reacted with the oxygen to form a carbon dioxide. And this is also carbon oxidation state is 0 and the oxidation state, oxygen oxidation state is also 0. But after the compound formation, the carbon is converted into +4 oxidation state and oxygen is converted into -2 oxidation state. If oxidation state increase, it will undergo oxidation. If the oxidation state will be decreased, it will undergo reduction. So in this, carbon undergo oxidation because the oxidation state or oxidation number will be increases, and oxygen undergo reduce because oxidation state will be decreases, and elements are combined to form a compound, that's why it is one of the combination redox reaction. Next, another one example, hydrogen gas, 2 moles of the hydrogen gas is reacted with oxygen gas to form 2 moles of the water molecules. So here is also hydrogen is a 0 oxidation state, but after the compound formation it will converted into +1 oxidation state. Oxygen is a 0 oxidation state, but after the compound formation it will converted into -2 oxidation state. So hydrogen undergo oxidized, oxygen undergo reduced. Next, last one is 3 moles of the magnesium is reacted with nitrogen gas to form magnesium nitride Mg3N2. So in this, magnesium undergo zero oxidation state. Here is also nitrogen having zero oxidation state, but after the compound formation, Mg is converted into +2. Next, nitrogen is converted into -3. Okay, so these reactions are example for combination redox reactions, because two elements are combined to form a compounds. That's why these reactions are example for the combination reaction. Next one, decomposition reaction. Decomposition reaction, in this, compounds are converted into components. So decomposition reactions are exactly opposite to combination reaction, because here in combination reactions components are converted into compounds. In decomposition reactions compounds are split into components. So we will see with examples for best understanding. A redox reaction in which compound is split into components, at least one of which must be in the element state, is called decomposition reactions. So simply we can say that in decomposition redox reactions compounds are split into components. For example, we will see H2O, 2 moles of the H2O. Whenever we heating, it will be split into 2 moles of hydrogen gas plus 1 mole of oxygen gas will be formed. So here oxidation state of the hydrogen is +1 and the oxidation state of oxygen is -2. But after the completion of reaction, +1 is converted into zero oxidation state, that means reducing, and -2 is converted into 0, it is increasing. So here oxidation state will be decreased. That means hydrogen will undergo reduced, and oxidation state increase, that's why oxygen undergo oxidation. And the next example, sodium hydride, 2 moles of sodium hydride, it will be split into 2 moles of sodium solid plus hydrogen gas will be liberated. Now in sodium, Na +1 oxidation state and the hydrogen containing the -1 oxidation state. Already we know that if hydrogen is combined with the high electropositive element, the hydrogen oxidation state is always -1. So in free state, sodium oxidation state is 0 and the hydrogen oxidation state is also 0. So here sodium is converted into +1 to 0, means oxidation state will be decreases. That means sodium undergo oxidized, because oxidation state decreases. Oxidation state decrease means reduced. And hydrogen is converted into -1 to 0, means oxidation state increases, that's why hydrogen undergo oxidized or oxidation. Next, another example, potassium chloric acid, KClO3, it is converted into 2 moles of potassium chloride plus 3 moles of oxygen will be forming. So oxygen oxidation state is a free state, that's why it is a zero oxidation state. Potassium containing the +1 and the chlorine containing the -1 oxidation state. And here potassium containing the +1 oxidation state and oxygen containing the +5 oxidation state, and chlorine containing the +5 oxidation state and oxygen containing the -2 oxidation state. Now here potassium will not be changed because here potassium is a +1 oxidation state and a +1 oxidation state. That's why it is neither oxidized nor reduced. But in chlorine, +5 oxidations to -1 oxidation state. That means oxidation state will be decreases. Oxidation state will be decreases is nothing but reduction, means gaining of electrons, or reduction means chlorine undergo reduced. And oxygen oxidation state is a -2 to 0. -2 to 0 means oxidation state increases. Oxidation state increases is nothing but oxidized. So oxygen undergo oxidized and chlorine undergo reduced. So this is the information about decomposition reactions. But all decomposition reactions are not redox reactions. This is a very, very important note. For example, you take a calcium carbonate. Whenever we dissociate into calcium oxide, plus oxygen gas will be liberated. So it is also decomposition reactions, but it is not a redox reactions. So from this we can conclude that all decomposition reactions are not redox reactions. Here you will see calcium oxidation state is always +2, and here is also +2. Oxygen oxidation state is -2, here is also 0 and -2. Sorry, carbon dioxide here, carbon dioxide, not oxygen. So that's why oxidation state of the oxygen is -2. So here before the reaction, and means reactant oxygen oxidation state is -2. After the reaction, that means product also containing the -2 oxidation state. That's why it is not a redox reaction. So from this, all decomposition reactions are not redox reactions. So this is the information about combination redox reactions as well as decomposition redox reactions. The next one is, third one is displacement reactions. Displacement reactions. In this first one is metal displacement redox reactions. Best example for metal displacement redox reaction, that is a copper sulfate solution reacted with zinc metal to form zinc sulfate plus copper solid. So here copper oxidation state is a +2 and the sulfate oxidation state is -2. Zinc oxidation state is 0, but after the reaction zinc is converted into +2 and the copper is converted into 0 oxidation state. So copper +2 is converted into copper 0 oxidation state. +2 to 0 means oxidation state will be decreases. That's why here redox reaction will be takes place. Next, zinc undergo 0 to +2 means here oxidation state increases. That's why zinc undergo oxidation and the copper undergo reduction. So simultaneously oxidation as well as reduction takes place. That's why it is a redox reactions. But here zinc displaces copper ions. Cu plus 2 ions. So zinc is also metal. Here displaces. Which one is a displaces? Copper plus 2 means is a one of the metal. So zinc displaces copper plus 2 ions. That means metal displacement reaction it is called, because copper plus 2 metal ions are displaces. That's why it is an example for the metal displacement reactions. Next, another example, vanadium pentoxide V2O5 is reacted with 5 moles of the calcium to form vanadium is a solid plus calcium oxide. So here 5 moles of the calcium oxide will be forming. Equation is balanced. So here calcium displaces the vanadium. In previous reaction is also zinc displaces copper plus 2 ions. So like this, here is also calcium displaces the vanadium. That's why it is also metal displacement reactions. Next, another example, you will identify the oxidation state. Here vanadium can exhibit the +5 oxidation state, oxygen is a -2, calcium is 0. But after the reaction, vanadium is a 0 oxidation state and the calcium is +2 oxidation state and the oxygen is -2 oxidation state. Next, another example for metal displacement, titanium tetrachloride is reacted with 2 moles of the magnesium. Here magnesium displaces the titanium metal. That means titanium plus 4 ions. That's why titanium solid will be forming plus 2 moles of the magnesium chloride will form. Next, last one is chromic acid, chromium acid, that is a Cr2O3. Chromium acid is reacted with 2 moles of the aluminum. Aluminum displaces chromium ions. Chromium plus 3 ions is nothing but formation of aluminum oxide Al2O3 plus 2 moles of the chromium is a solid. So here is also chromium plus 3 ions, oxygen containing the -2 oxidation state, aluminum 0, but here aluminum containing the +3 oxidation state, oxygen containing the -2 and the chromium is 0. So here titanium is a +4, chlorine is a -1, magnesium is 0, titanium is +4, sorry here 0, titanium is 0, the magnesium is +2, chlorine is -1. Next, these are the example for metal displacement reactions. Now non-metal displacement reactions. Example for the non-metal displacement, sodium, 2 moles of the sodium is taken, it is reacted with 2 moles of the H2O water to form 2 moles of sodium hydroxide plus hydrogen gas will be liberated. So here sodium displaces hydrogen. Hydrogen is a non-metal, that's why this reaction is called non-metal displacement. Sodium displaces hydrogen. Next, calcium It is also reacted with 2 moles of the water to form calcium hydroxide plus hydrogen gas will be liberated. So here is also calcium displaces hydrogen. Next, magnesium is reacted with 2 moles of the H2O to form magnesium hydroxide plus hydrogen gas will be liberated. So here magnesium displaces hydrogen. Next, iron two moles of the iron reacted with 3 moles of the water to form Fe2O3 is nothing but ferric oxide plus 3 moles of the hydrogen gas will be liberated. Next one, zinc plus HCl. Zinc metal is reacted with 2 moles of the hydrochloric acid to form a zinc chloride ZnCl2 plus hydrogen gas will be liberated. So here is also zinc displaces hydrogen. Here iron displaces hydrogen. And the magnesium is reacted with 2 moles of the HCl to form magnesium chloride plus hydrogen gas will be liberated. So here is also magnesium displaces the hydrogen. And iron is reacted with 2 moles of HCl. So ferrous chloride will be forming and hydrogen gas will be liberated. So here is also iron displaces hydrogen. So these are the example for non-metal displacement reactions. So another one is non-metal displacement reactions is fluorine is only that replace oxygen. Here fluorine is reacted with water to form hydrogen fluoride plus oxygen gas will be liberated. So fluorine can replace oxygen, only fluorine. Next, remaining chlorine, bromine, iodine did not replace the oxygen. And as well as fluorine can replace all the halogens which are chlorine, bromine, iodine. For example, we will take in first example. Fluorine is reacted with 2 moles of the HCl to form fluorine replace or displace. Fluorine will displace chlorine. That's why here hydrogen fluoride will be forming 2 moles of the plus chlorine gas will be liberated. So like this, here is also bromine is also there. Fluorine can displace bromine. If here iodine is there, fluorine can displace iodine. So that is the capacity of fluorine. Okay, so fluorine can replace or displace all the halogens, but chlorine only bromine and the iodine can displace, not fluorine. Understand? For example, here you will take in chlorine. Chlorine here reacted with 2 moles of the hydrogen fluoride. If you take in, so this reaction will not be possible because chlorine not displace the fluorine, because fluorine is a high electronegativity and the strong element comparing with chlorine. That's why chlorine will not displace the fluorine, but chlorine can displace the bromine as well as iodine, will be okay. And if you take in the bromine, so bromine did not displace the fluorine or chlorine, only displace the iodine only. So this is the information about non-metal displacement. If you will see the example, so here chlorine does not displace the fluorine, that's why it is a not possible reaction, but chlorine can displace the bromine. Okay, chlorine will displace bromine and the chlorine will displace iodine. So if you take bromine, bromine did not displace the fluorine and bromine did not displace the chlorine, but bromine can displace the iodine only. Okay, so these are examples, and these examples are enough for non-metal displacement reactions. Next, disproportionation reactions. Redox reactions is very important. So disproportionation reactions are very important. In disproportionation reactions, an element is simultaneously oxidized as well as reduced. So that reactions are called disproportionation reactions. Disproportionation means simultaneously oxidized as well as reduced, only one element. For example, you take a hydrogen peroxide is dissociate into 2 moles of the water plus oxygen gas will be liberated, okay, when 2 moles of the hydrogen peroxide is taken. So in this reactions, hydrogen oxidation state is +1 and the oxygen oxidation state is -1. We know that general oxidation state is -2, but here in peroxide oxygen oxidation state is -1. So here after the reaction, +1 oxidation state is a -2 and here is also 0. Oxygen oxidation state, you will find here one oxidation state undergo -1 oxidation state is undergo -2 as well as 0. That means -1 to -2, 0, -1, -2, +1, +2. So oxidation state, oxygen oxidation state is going from the -1 to -2. -1 to -2 means here gaining of electrons. Gaining of electrons means is a reduction. Gaining of electrons is nothing but reductions, or oxidation state will be decreases. Oxidation state will be decreases. If you see another oxidation state, that is a -1 to 0. -1 to 0 means oxidation state increases, that's why it is a oxidation. Another one is, it is a oxidation. Loss of electron is nothing but oxidation reactions, or oxidation state will be increases. Here oxidation state will be decreases. So only one element, that is a oxygen, undergo oxidized as well as the reduced. That's why this is the reaction is example for the disproportionation reactions. Another one is, So another examples, more example for disproportionation reactions. Here phosphorus having zero oxidation state, but whenever after the after the reaction it will be converted into here -3, and in this phosphorus oxidation state, only phosphorus oxidation state is a +1. So here one element undergo oxidation as well as the reduction. So 0 to -3 means oxidation state will be decreases, that's why it is a undergo reduction. So here increases, 0 to +1 is a increases, that's why it will undergo oxidation. Next, sulfur oxidation state is 0, but after the reaction -2 as well as +2. So one is minus, one is plus, and one is 0. So that's why only one element undergo oxidation as well as reduction. Next, chlorine 0. So here is also +1 oxidation state, and in this -1 oxidation state. So one is minus, ఒకటేమో మైనస్ ఉంటుంది, ఒకటేమో ప్లస్ ఉంటుంది, ఒకటేమో ప్లస్, ఒకటి మైనస్, ఒకటి ప్లస్, ఒకటి మైనస్. One is neutral. Okay, so one element undergo oxidized as well as reduced, that's why these reactions are called disproportionation reactions. But one of the exception is there, that is fluorine. So this reaction, that means fluorine is reacted with sodium hydroxide, it is not a disproportionation reactions, because fluorine having a abnormality properties, because having a less atomic size, absence of d orbitals. So that's why here fluorine can exhibit the abnormality, that means different properties. Here fluorine high electronegativity, that's why electrons are towards the fluorine atom, that means always it exhibits the minus oxidation state but not plus oxidation state. So already we know that whenever if the reaction is belongs to the disproportionation reactions, one oxidation state is a positive and another one oxidation state is a negative, but fluorine is always negative because high electronegativity element. So that's why here fluorine is reacted with the sodium hydroxide is not a disproportionation reactions, it is an exception. And here is also hypochlorate, the name is hypochlorate ion, which is a ClO minus ion is called hypochlorate ion. It is a bleaching agent, one of the bleaching agent. Hypochlorate ion. Hypochlorate ion, it is a bleaching agent and it oxidize colored compound into colorless compounds. Okay, it oxidize colored compounds into colorless compounds. So this is called hypochlorite ion. Hypochlorite ion, very very important. So this is the information about types of redox reactions. One is combination reaction, second one is decomposition reaction, and the third one is displacement reactions. In this further again two types, metal displacement redox reactions and non-metal displacement redox reactions, and the last one is disproportionation reactions. Disproportionation reactions are very very important because only one element undergo oxidation as well as reduction. Thank you.